So this video is on the class exercise work. This is the solution. So the problem we have is that water is being pumped out of a conical tank that is situated such that the point is at the top. The tank is 20 feet in depth and 24 feet in diameter, and there's a 5-foot spout at the top of the tank. And we have to calculate the work that is being done pumping the water out of the top half of the tank if the water level in the tank is currently 2 feet from the top of the tank. So I showed that with the purple 2 and the 10. So as with any of these problems, what we need to do is we need to determine certain things. And one of the things we need to do are the bounds of integration. What are the bounds of integration? Well, the bounds of integration will represent the limits of where we are pumping water. So we are pumping water from x equals 2 to x equals 10. And so I am going with x equals 0 here and x equals 20 at the bottom. This is the way that I set my problems up in my notes. This is the way that I like to do it. There are other ways of doing it. So x equals 0 is always at the top and increases downward. So that means that we are pumping water from 2 to 10. So x is going to be less than or equal to 10, greater than or equal to 2. The other thing that we need to determine is the distance that we are pumping water. Okay, so the distance that we are pumping water, we're going from an x value, from x equals 2 to x equals 10. So the distance is going to be some distance x plus the 5-foot spout, plus this 5 foot up here. So the distance is simply x plus 5. And then finally, we need to calculate the volume of a slab of water. Well, since it's a conical tank, a cross-section, any slab is going to be pi r squared times the height. That would be the volume of any little slab of water. So all we need to do is figure out what the radius is at any given point. And so we can do that by using similar triangles. So we know that the height of the tank, and that's what the bright yellow lines are on the tank. So we know that the height of the tank, 20, can be compared to the radius, 12, as any given distance x is to its corresponding radius. Or the radius is going to be 12/20 x, which is 3/5 x. So putting that in here, we have pi times 3/5 x squared, and h is going to be delta x. So we have 9/25 x squared pi delta x. That's my volume. Then what we do is we put it all together in an integral. And so the integral work is equal to the density times the volume times the distance that the water is being pumped. All right. As an integral, this is equal to rho times the integral from A to B of the volume times the distance dx. And so we know all the component parts of that. Work is equal to 62.4, the integral from 2 to 10. Our volume was 9/25 x squared pi. The distance is x plus 5, and then the dx. So what I would do is I would plop that into Desmos, see what you get, and come back and compare that later. So I'm just going to circle that, put that in Desmos, see what you get as a decimal number, and then when you're done with your integrating, you want an answer in terms of pi, and then just convert that into a decimal. Okay, so where do we go from here? Well, let's get the pi out in front. So W is equal to 62.4 pi times the integral from 10 to 2. And so we're going to have 9/25 x cubed plus 5 times 9 is 45 25ths x squared dx. Now I'm going to simplify that a little bit, because if I don't, I'll get all screwed up later on. 62.4 pi times the integral from 2 to 10, and that's 9 25ths x cubed plus 5 goes into 45 9 times over 5 x squared dx. All right. Now I am all set to integrate. Power roll time. Let's go to green. So work is 62.4 pi. And so 9 25ths x to the fourth divided by 4 is 9 100ths x to the fourth. Plus we have 9 fifths x cubed divided by 3. So 3 times 5 is 15. So that's going to be 9 15ths x cubed evaluated from 2 to 10. And I'm going to simplify the 9 15ths. They both have a factor of 3. So we have 9 100ths x to the fourth plus 3 fifths x cubed. It's just going to make the computations a little bit easier here. Now let's substitute in 10. W is equal to 62.4 pi, and I'm going to go to blue. And so we have 9 100ths times 10 to the fourth power. Well, 10 to the fourth power is 10 squared times 10 squared. So I'm just doing a little fancy algebra here. 10 squared times 10 squared, that's going to cancel out with one of the 10 squareds. I'm going to have the other 10 squared, which is 100 times 9 is 900. Same thing, x cubed is 1,000. 5 goes into 1,000 200 times 3 is 600. All right. Minus, and let's do this in another color. We're going to have 9 100ths times 2 to the fourth. So we have 9 100ths times 16 plus 3 fifths times 8. Okay. So let's go back to work is 62.4 pi. And in the blue, I have 1,500 minus, and let's see, 9 times 16 is 144 100ths. I'll do that in violet again. So that is 144 100ths over 24 fifths. Now 144 100ths, let's see, they both have a factor of, let's see, 144, 72 over 50, 36 over 25. So I have 36 over 25 plus 120 over 25. And so that is 156 over 25. And so we have, putting it all together, we have 62.4 pi. And in blue, now I have times the 1,500 minus that. And of course, that's all of that. All right. So what does all of that end up being? If you put that into Desmos, which I've already done, 1,500 minus 6.24 times 62.4 is 93210. So we have 93210.6 pi. That is the answer that I am looking for. Then, of course, if you go back to Desmos and you multiply that by pi, all right, so if you take that and multiply that by pi, you're going to get 292,829.8, which is exactly as it is above it with my basic integral that I set up. So my computations and my integral coincide. So they're either both correct or they are both very wrong. You could always have the right answer to the right problem or the right answer to the wrong problem. Okay, so this is the answer that I would be looking for in terms of pi. And the reason that I'm always looking for answers in terms of pi is because clearly you can just get the decimal answer in Desmos. If I just want to see you set up the integral and not actually work through the computation, I might ask you for the value as a decimal. All right, so that is a solution. Hope it was fun for you. Good review for the exam.